So suppose you have the integral -2 to 2, 2y minus 4 to -2y plus 4, and you're integrating f of x comma y dx dy. Suppose you're given this integral and you're asked to switch the order of integration. What would you do? Well, first you have to sketch the domain, or else you can't figure out what you're doing, what this integral is integrating. So you need to know where this is being sketched.
Is 1A?
Hmm?
Is this 1A on the review sheet?
No, it's 1b.
1B.
Okay. So first you have this dx, therefore you should think of this as x equal to and x equal to. And these should be thought as graphs in two-dimensional plane. Right? So the language I'll keep using is curve to curve, point to point. So it's a graph of a function to another graph of a function, and it's a value of a variable to another value of a variable. That means I really need to graph this in order to figure out what the integral is being done over. Okay? Now I don't know the graph of this until I solve for y, so I'm going to solve for y. Subtract 4, divide by -2. And then you have 1, 2, with -1/2 being your slope. So it's like this. And I'm drawing it so that it's rise is -1 and run is 1, 2. Rise is -1, run is 1, 2. That means this point is? What's this coordinate?
4.
Okay, so that's the graph. Now let's try to draw this one. X equal to 2y minus 4. X plus 4 equals to 2y. And if you divide by 2, you get 1/2 x plus 2. In this case, it's 1, 2. Again, the y-intercept is 2. But this time the slope is rise 1 and run 2. So it's this way. Alright, so putting those two together, this is what I get. I get the graph. Two here, 4 there. And these are the two graphs. Okay, now, because this is dx, what you're trying to do is you're trying to go right. Actually, that's a little weird because you're. Oh, no, you're going right. Sorry. You're going right, so you're going this way. On the other hand, your y values are from -2 to 2. So what does that mean? Your y values are from -2 until 2. So what it means is that you're not just painting this region here, but it's going all the way down here, covering this region. So that's the domain that you're integrating over. You begin at this curve, you end at that curve. That's what it says, right? Starting from this graph, you end at that graph. where on the other hand, y values are from -2 to 2, so these brushes are, you're painting at level -2 until 2. And that's what it paints. Okay? You've painted this region. Any questions so far? Does it make sense? All right, now let's actually think about how to change the order of integration. The order of integration is now being changed to dy dx. Now, having the dy inside means that you're trying to paint this in what way?
Upward.
Going upwards, right? Upwards. That's what you're trying to do, trying to integrate upwards. In that case, you need to describe what the beginning graph is, and you have to describe what the ending graph is. However, there's a problem with trying to paint the region upwards. Do you see the problem? There are two graphs, right? On the left side and on the right side, you have two graphs. And therefore, you either have to come up with a single formula for describing this entire thing, which, by the way, is possible. You can use absolute values in some strange way to describe it. I think I can even figure out what it is. It should be this graph here. You can even write it as y equals to 2 minus 1/2 absolute value of x. Okay? So if you knew that, then you can say, oh, it goes from y equals to -2, and it reaches the top, which is this graph. Okay? So if you were able to do that, then you can just come up with a single integral and write down -2 for the down and that for the top and the x values. However, I don't think a lot of you will be able to come up with that equation. So rather than taking that approach, let's do the following. We will just represent this integral as two integrals. So here's one, and here's another. Two integrals. So when on this side here, you're trying to go upwards, starting from y equals to -2. This line is y equals to -2, right? And what is this? This is the graph of this is y. No, it's not that one. Sorry, it's this one, right? This one, y equals to 1/2 x plus 2. So for this, we can say the integral is from -2, y equals to -2, to y equals to 1/2 x plus 2. Okay, you don't have to put y there, but if it helps, you can put y there. That's still okay too. You start from this graph and you end at that graph. Okay? The fxy doesn't change, and we're trying to do dy dx. Now we have to figure out the values for x now. This last integral shouldn't have any variables in there. Okay? I've seen people just switching these two around, and that's how you change the order of integration. Please don't do that, okay? That just means that you don't know anything about double integrals. Okay? Whenever you represent something as a double integral, these usually have x somewhere. It doesn't have to, but usually. But this last one can only be values. You can never put x's or y's in here, okay? All right, what are the values of x in this region?
-8, 0.
Yeah, so this is 4, so that must be 4 because there's a symmetry, right? -4. And then this, because this is 2 and -2, just by like triangles, you kind of see that this is -8. Or if you think you can't get it that way, you can just simply say, well, let's see, if y is -2, you plug it in here, what's the x value? You get x equals to -8. So you know that the coordinate of this is -8 comma -2. Then if you know the coordinate, then you can say, oh, x value varies from -8 to 0. So that's how you would do it if you were sort of weak with geometry, couldn't figure out this. Okay? I mean, how do you find intersection of this graph and that graph? You just take one and set it equal to each other, right? No, you can't. In this case, this is like y equals to, and this is like x equals to. So you can't set it equal to each other. If you really want, you can do this. Set this one equal to that, because they're both y equal to. So you can set these two equal and solve for x, you get -8. But better one is, since y is -2 on this line, plug that in here, you get the x value, so you know that the intersecting point is -8 comma -2. So that's what we get for this left side. But that's not all, right? So we have to do the other one. In other words, when you go from dx dy, sometimes you may end up with 2 integrals rather than 1. In some cases, you may get 3. So don't think you're writing something strange because you have more than one integral. It may happen that the representation in the different order is much harder than the given one. Okay? All right, f x comma y dy dx. Now what about this? It still starts from -2 and it ends at, so you start at -2 and you're going up and it hits this one, which is this graph right here, right? So it's -1/2 x plus 2. And then for x value, what's the x value? 0 to 8. It's a symmetric domain, so if this is -8, this must be +8. And if you didn't believe me, you can still figure that out by plugging in this -2 in here, and you get the value of x as 8. So you know that this coordinate is 8 comma -2. Therefore, x value goes from 0 until 8. That's what you're right.